Welcome to This Explainer. If you've ever found yourself just staring blankly at a massive spreadsheet, literally manually checking row after row to see, I don't know, who gets a bonus or which accounts are overdue, well, you are absolutely going to love today's topic because we're taking Excel from being this tedious manual data entry tool and turning it into a fully automated decision maker. And we're doing it by mastering the IF function.
Okay, let's dive into this. We're taking a nice progressive crawl, walk, run path today. First, we'll look at the magic of if. Then we'll set up your first logical test. From there, we'll master nested if formulas. And finally, we'll apply it all to real-world business applications. So, part 1, the magic of IF, making Excel decide. At its core, the IF function performs what we call a logical test. Honestly, the best way to think about it is it's like a bouncer at a club. A very strict, very efficient bouncer. That bouncer checks an ID, that's your condition, and based on what that ID says, they send you down one of two paths, right? You're either on the list or you're not. Well, Excel does the exact same thing with your data. It checks a specific condition that you set, and it instantly returns different results based on whether that condition is met or not. This is the exact tool professionals use to instantly calculate pass or fail statuses, automatically figure out who met their quota for a bonus, determine approval routing, or even flag risk categories.
To actually make this magic happen, you really just need a simple three-part structure separated by commas. Think of it as Step 1, the condition. Like, what rule are we asking Excel to check? Step 2 is the value if true, meaning what should Excel spit out if the rule is actually met? And Step 3 is the value if false. What happens if the rule is broken? This three-part setup, it is the absolute foundation of all automated logic.
All right, moving into our walk phase. Section 2, your first logical test, a simple binary choice. Let's look at a classic scenario. Imagine you're a teacher. You've got a huge spreadsheet full of student marks, and the passing grade is a 40. So we have a stark binary outcome here. If a student scores a 35, obviously less than 40, we want Excel to automatically label that a fail. But if they score a 75, greater than 40, Excel should instantly spit out pass. We've got two clear, completely opposite paths. So here is exactly how we translate that into Excel's language. Let's assume our student's mark is sitting right there in cell A2. We just type equals IF, open parenthesis, A2 is greater than or equal to 40, comma, quote pass, comma, quote fail. It maps perfectly to our three steps. The condition is A2 being greater than or equal to 40. If that's true, Excel prints pass. If false, fail. The very millisecond you hit enter, Excel checks that condition and gives you the right status. And the best part? You can drag that formula down 1,000 rows, and boom, your grading is literally done in a second.
Now that binary pass-fail thing is incredibly useful, but let's pause for a second here, because life, and definitely business, is really that simple, right? So what if you have more than two outcomes? What if it's not just pass or fail, but you need to assign actual letter grades, like A, B, C, D, and F?
That brings us perfectly to our jog phase in Section 3, Mastering Nested If Formulas, Stacking Your Logic. First things first, do not let the word nested intimidate you. All it means is that we're placing multiple conditions inside one another. So instead of just pass or fail, let's map out a multi-tiered grading system visually. If a student gets an 80 or above, they earn a distinction. If they don't quite hit 80, but they're 60 or above, that's first division. 40 or above is a standard pass, and anything below 40, that's a fail. 4 possible outcomes simply means we have to stack our conditions.
Now, what's really interesting about this setup is how all those different thresholds compress down into a single line of logic. We start off exactly like before. If A2 is greater than or equal to 80, output distinction. But if it's not, we don't just default to fail. Actually, scratch that. We start a brand new I formula right inside the old one. We're telling Excel, okay, if it's not 80, then check if it's 60. And if it's not 60, check if it's 40. Excel is basically acting like a detective, reading left to right. It checks the first condition. If it's a match, it stops immediately. If not, it steps down the stairs to check the next rule and the next until it finds a true match or hits that very last false option, which is fail. All right, time for the run phase. Section 4, Real-World Business Applications, Taking the Training Wheels Off. Imagine you're at a bank reviewing loan applications. The absolute core policy is that an applicant has to have a salary of $50,000 or more to be eligible. The formula for making this high-stakes decision uses the exact same structure we just learned. Equals if
B2 is greater than or equal to 50,000, output eligible, otherwise, output not eligible. See? Exact same mechanics, we're just applying it to financial data now. And the crucial point here is that this logic applies literally everywhere in the corporate world. We just saw banking decisions with loan approvals, but you can use this for employee evaluations, automatically tagging anyone who scored above a 4 on their review for a promotion. Or sales targets, calculating a 10% bonus if a rep hits their quota and 0 if they don't. You can even use it for budget analysis, automatically flagging a cell as over budget if expenses cross a certain threshold. Seriously, right after this explainer, I challenge you to open up a spreadsheet and try this out. Build your own pass-fail formula. Maybe try stocking a grade formula, or set up a salary eligibility check. Doing it yourself is absolutely how it clicks. So let's take a quick step back and look at the journey we just took. We went from basic syntax all the way to complex business logic. We mastered logical tests, the 3-part if syntax, nested ifs, and real-world examples. You now have a solid foundational grip on making Excel do the hard thinking for you. And the next logical step in your learning path? That's going to be combining conditions using the and or functions, which will give you even more precise decision-making power.
As we wrap up, I want to leave you with this final thought. Now that you know how to teach your spreadsheet to think and evaluate conditions on its own, with Excel making the decisions, what will you automate next? Thanks so much for joining me for this explainer, and happy—
Thanks for listening, dropping by, getting high on my vibe.